Here we have some typical coin problems that you'll be asked to solve in a normal algebra class. And first of all, before we get started on these, I just have to say that I find these problems extremely silly. Usually there's only two types of coin that are collected for some reason, although we never know that reason. We know how much money exactly there is, so it's been counted, and in fact we know some details about the coins themselves. Like in this case, we know that there were 115 more nickels than quarters, but somehow the only thing we don't know is how many of each type of coin there are, even though we know there are 115 more nickels than quarters. And somehow we want to know that amount for some reason. So these problems don't make a lot of sense to me, but let's just humor the problem writer and try to do the math on this. This one says Ivan's piggy bank contained only quarters and nickels, and when he counted the money there was $21.05. If there were 115 more nickels than quarters, how many of each type of coin did Ivan have in the bank? So we're actually trying to find two things here. We're trying to find the number of quarters and the number of nickels. So we're going to have two variables, which means we're going to have two equations to be able to solve this. This will be a system of equations. I'm going to say Q is the number of quarters and N is the number of nickels. And then this fact that we know exactly how much money there is, that's really handy because we can write one of these equations right away. If Q is the number of quarters, if you want to find the value of that, how much money it's worth, you just multiply that by the value of a quarter. So 0.25 times Q is your money in quarters, and in a similar way, 0.05, because a nickel's worth 5 cents, times the number of nickels is going to give you the value of your nickels. And all of that added together is 21.05. So we're halfway there. We've got one equation. The other equation we can make here comes from this fact that there are 115 more nickels than quarters. The way to translate that into algebra is that the number of nickels is the number of quarters plus 115. So that's 115 more nickels than there are quarters. Now we can try to solve this. The way these equations are set up, it tells me that maybe substitution is a good way to go about this. We've got this equation solved for n, so we could take this expression, q plus 115, and plug it in for n up here. Then we'd have one equation with just q, and we could solve for that. So I think that's the strategy I'm going to use. Let's try that. So we get 0.25q plus 0.05, and instead of n, now we've got q plus 115. And all of that equals 21.05. All right, so we need to distribute the 0.05 here. So 0.25q plus 0.05q plus whatever 0.05 times 115 is. I think I'll bring out my calculator, and that's 5.75, and that equals 21.05. Now we need to combine our like terms. We've got 0.25q and 0.05q. That adds up to 0.3q, and then we've got 0.5.75 equals 21.05. We want to get the q term alone, so let's subtract 5.75 from both sides. And we're going to get 0.3q equals that's 15.3. And finally, to solve for q, we're going to divide by 0.3. This number here, 15.3, is going to get bigger when we divide it by 0.3. Some people get confused, how can a number get bigger when you divide? But when you divide by a number that's less than 1, that's what happens. So you can watch on my calculator. 15.3 divided by 0.3 is 51, and that is q. So the number of quarters is 51. The number of nickels is just quarters plus 115. So nickels, what is that going to be, 166? And there we have it, the number of quarters and the number of nickels. So Ivan can go around telling people exactly how many nickels and quarters he has now. All right, let's try one more of these problems. This one says, when Karen counted the nickels and dimes she earned at the yard sale, there were 206 coins. If the total was $17.25, how many of each kind did she have? So pretty similar to the last one. We can make this value equation right away. We're dealing with nickels and dimes here, so we can say nickels, n is the number of nickels, d is the number of dimes. So 0.05 times the number of nickels plus 0.1 times the number of dimes is going to add up to 17.25. Now our other equation is pretty easy. It says the total number of coins is 206. So that's the number of nickels plus the number of dimes is going to equal 206. And my approach on this one would be to do substitution again. And to do that, I want to solve this equation for one variable or the other. It doesn't really matter which one. I think I'm just going to subtract d from each side so that we get n equals 206 minus d. And then we'll substitute that expression in up here for n. So let's try that. So 0.05 times 206 minus d plus 0.1d equals 17.25. Now we've got one equation, one variable. Let's distribute the 0.05. So 206 times 0.05, that's 10.3. And 0.05 times a negative d is minus 0.05d plus 0.1d equals 17.25. All right, we can combine the negative 0.05d and the 0.1d. That's going to be a positive 0.05d. We've got our 10.3 and equals 17.25. And then we'll need to subtract 10.3 to get the d term alone on one side. So 0.05d equals, that's going to be 6.95, I think. And then finally we'll divide that by 0.05 to get d alone. And I get d equals 139. So that's the number of dimes. The total number of coins is 206. So all I need to do is subtract 139 from 206. And we get 67 for the nickels. So that's our answer, and that's some work with coin problems.